This is a short tutorial on conversions, how you convert between different units in a lab. So let's look at an example. You need to convert 4 molar to millimoles per mil. Well, the first thing to remember is that we can rewrite 4 molar as 4 moles per liter. And if we do that, then we can start to break down this conversion. So here we are at 4 moles per liter. Now if we multiply that to get rid of moles, we know that 1 mole is 1,000 millimoles. So we can get rid of the moles and we end up with 4,000 millimoles per liter. We still want to get that to mils, so we can do that in the following step. Now taking our 4 millimole per liter down here, and we know that 1 liter is equivalent to 1,000 mils. So this actually is, this ratio is 1, because we know that 1 liter and 1,000 mils are equivalent, but we can use this to get rid of liters, and then we end up with millimole per mil. We're going to divide this, and we end up with 4. And notice that we started with 4 molar, and we end up with basically the same unit 4, but now we have millimoles per mil because we've changed both the numerator and the denominator to the same extent by 1,000. We can use that same logic now to further convert this, and in this case we'll go from millimole per mil to micromole per microliter. Both of those values are changing by 1,000, so we also end up here with a simple 4 micromoles per microliter, and that's equivalent to 4 molar. Let's convert 0.7 molar to millimole per liter. So again, let's start with just rewriting this. 0.7 molar is 0.7 moles per liter, and if we're trying to find millimole per liter, we're going to do similar types of calculations. In this case, we've got, again, 1,000 millimoles per mole. That's the same as saying 1. And we can multiply our 0.7 moles per liter from up here times that value so that we end up with 700 millimoles per liter, and that gets us to where we want to up here. Let's convert 25 parts per million to milligrams per liter and then to a percent solution. So one of the things that we're going to need to know for this, because we're in a biology system typically looking at water as the solvent, and we need to know something, which is that water weighs 1 gram per milliliter, and that will become very useful. So 25 parts per million can be written as 25, and the parts per million is in the denominator. And that makes it useful when we're trying to convert this to milligrams per liter. So to get to milligrams per liter, let's recall that 1 liter is equivalent to saying 1,000 milliliters, and that's also equivalent to 1,000 grams because we know that water weighs 1 gram per mil. So let's set up a ratio. 25 is to 1 million as X is to 1 liter, or in this case I'm substituting the 1,000 grams because that's equivalent to saying 1 liter. And then we can solve for that and find that X is equal to 0.025 grams, and if we move the decimal point over, that means we've got 25 milligrams. Hence, 25 parts per million is 0.025 right here, grams over 1,000 grams, or 25 milligrams over 1,000 grams. And if we go back and substitute, we know that that's 25 milligrams per 1,000 mil, or 25 milligrams per liter. So 25 ppm is the same as saying 25 milligrams per liter. Let's do the last part, converting 25 parts per million now to a percent solution. And we're going to start with the previous calculation, the 25 milligrams per liter, and go straight to percent from that first. Critical to understanding this, you need to remember that percent means grams per 100. And typically in the biology lab, we're talking about grams per 100 mils. So with that in mind, first let's convert milligrams to grams because we are trying to get to grams per 100 ml. So the first part is milligrams to grams. So we start with our 25 milligrams per liter times 1 gram over 1,000 milligrams so that we can get rid of milligrams. And we're left with 25 grams over 1,000 liters because we're preserving those numbers. And we want to simplify the denominator to 1, so that gives us, when we divide by 1,000, 0.025 grams per liter. Next, let's work on the per 100 portion. So to do that, we're going to remember that 1 liter is equal to 1,000 mils, so we can take this value and rewrite that as 0.025 grams per 1,000 mils. And now we can reduce that so that we get to 100. Now to do that, we're going to move the decimal point over 1 in the denominator so that we go from 1,000 to 100. And we need to do the same in the numerator. So we're going to go from 0.025 to 0.0025 grams. Now we've got it in the form that we want, grams per 100 ml. So this number becomes your percent, 0.0025%. Now I want to point out that you can go directly from parts per million to that same number. And that's shown here. So we're going to start with our 25 parts per million, and again, as we did on the previous slide, we wrote that as 25 over 1 million. If we divide that, it becomes 0.000025, and if we move the decimal point over 2, because that accounts for our 100, then we get exactly the same number, 0.0025, and that's our percent from 25 parts per million.